Hi guys, so today we're going to be doing lesson 3-5, proving lines are parallel. Before we get started with our first example, we're going to take a look at some of our postulates and theorems. Okay. So here it tells us if two lines in a plane, so here we have two lines in a plane, if they're cut by a transversal and those corresponding angles are congruent, then we know the lines are parallel. Okay. They call this postulate 3.4 here. Again, I will not accept if you write postulate 3.4 because 3.4 in this book is different from 3.4 in other geometry books, which is not helpful overall. What this is called, this is known as the converse, right? Because we're switching our if and then. This is the converse of the corresponding angles postulate. Okay. So this is the converse of that. Okay. The next one here is, they call it the parallel postulate, so I'm okay if you name it that way. If given a line and a point not on the line, then there exists exactly one line through the point that is parallel to the given line. Okay. The next one, these are all converses. This is the converse of the alternate exterior angles theorem, right? So this time, instead of having our conclusion be alternate exterior angles are congruent, this time, if the alternate exterior angles are congruent, then the lines are parallel. Okay? This is the converse of the consecutive interior angles or same side interior angles. Okay, again, it flips the conclusion and the hypothesis. So this time, if your same side interior angles are supplementary, then the lines are parallel, right? Because if you remember, same side interior and same side exterior, they're not congruent, they're supplementary, okay? So keep that in mind. This one is alternate interior, the converse of that, right? So if your alternate interior angles are congruent, then your lines are parallel, okay? And then this one, if two lines are perpendicular to the same line, then the lines are parallel. Okay. So again, these are all converses of ones that we've learned in previous lessons because they flip the hypothesis and the conclusion. Okay, and these are how we can prove that lines are parallel. Okay. So starting with example 1, okay, it tells us that in this figure, segment BG, which is right here, it bisects angle ABH. And so what that should tell us then is that this angle here is congruent to this angle here, right? Because it's bisected. Okay. Now we're going to determine whether any of these lines are parallel, right? So obviously we don't have to worry about BG or BH here because they intersect our three lines. So really what we're looking at are these three lines and seeing if they're parallel, okay? Again, in geometry, it doesn't matter what it looks like. It's what matters what you can prove. Okay, so even though it looks like all of these lines are parallel right now, it's only true if we can prove it. Okay, so first thing I kind of notice here is that there's a triangle. Okay, and if you remember, triangles are add up to 180, right? So here, my angle BDF plus this 45 plus this 65 should equal 180 degrees. Okay? So 45 plus 65 gives me 110. Okay, and then when I subtract the 110 over, it tells me angle BDF is 70 degrees. So angle BDF here is 70 degrees. Okay? And then here, what you notice is that this and this are two sets of lines intersected by a transversal. These are corresponding angles, and they are congruent. Okay? And so, because of the converse of the corresponding angles postulate, right, if corresponding angles are congruent, those lines are parallel. And so what that means is line DF is parallel this is the sign for parallel, is parallel to line GH, okay, because of the corresponding angles, because of the converse of the corresponding angles postulate. Okay. And that is because angle BDF is congruent to angle DGH. Okay. So now I've proven that these two are parallel. Okay. And so now if I can just prove line AB is parallel to one of these, that means they're all going to be parallel. Okay. So here, earlier we knew that BG bisected angle ABH. Right. So BG here bisected this angle, and so that's why I marked it in pink that they're congruent. So if this one's 45, that means this one has to be 45 degrees as well. Okay. If you notice, the 45 and the 70 are alternate interior angles. Alternate interior angles, if they're parallel, they should be congruent. Okay. But since they're not, that means they're not going to be. Okay. So this means that line AB is not parallel to line DF, and as a result, AB is also not parallel to line GH because angle ABD is not congruent. That's just my symbol for not congruent because I'm too lazy to write it all out. Is not congruent to angle BDF. Even though they are alternate interior angles. Right? Because if they were parallel, these alternate interior angles would be congruent. Okay. So now you're going to try CYP1 here, and then state any postulated theorems that justify. Okay, so you should have gotten line A is parallel to line B. The reason why is because angle 2 and angle 8 are alternate interior angles, and if they're congruent, the converse of the alternate interior angles theorem tells us then that those lines are parallel. Okay, we can't tell if L and M are parallel. We don't have enough information. Okay, so there you go. Okay, so example 2 asks us to find x and the measure of angle RSU so that M and N are parallel. Okay, so if we want these to be parallel, first we should notice that these are corresponding angles. So corresponding angles. Okay, and the corresponding angles postulate tells us that if we have parallel lines, the corresponding angles are congruent. Okay, so here we would want them to be congruent. So we're going to set them equal to each other. 8x plus 4 equals 9x minus 11. Right? I'm going to subtract 8x on both sides. That gives me x minus 11. I'm going to add 11 on both sides. That gives me 15 equals x. So that's part of my answer. And then now, since angle RSU is 8x plus 4, and I know that x is 15, I can substitute 15 in. Okay. 8 times 15 is 120. And 120 plus 4 is 124. And so the measure of angle RSU is 124 degrees. Okay. And there you go. So now, if you wanted to check, if you plug in 15 here, you should get the same answer. Okay. So why don't you try CYP 2A and 2B, and once you're done, come check your answer. Okay, for 2a, you should have gotten x equals 11.375, and for 2b, you should have gotten the measure of angle JKM is 97.375. If you got those correct, move on to example 3. If not, here's your explanation. Okay, so here, angle JKM and this angle here don't have a specific relationship right now. Okay, however, this angle and this angle do. Okay, this angle and this angle here are vertical angles, so they're congruent. Okay, and then, so this angle would also be 7x plus 3. Then, these two angles are same side or consecutive interior angles, which means that if these are parallel, they should be supplementary. They should equal 180. Okay, and so in order for them to be parallel, they have to be supplementary equal to 180. So I added the two of them to equal 180. Okay, 7x plus 9x is 16x. 3 minus 5 is negative 2. Add 2 on both sides. Divide by 16 on both sides. I get this. Okay, fractions are answers too, so don't discriminate. Okay, it doesn't necessarily mean that you did something wrong. In reality, in the real world, often it's going to be a decimal answer. Okay, so once I have that, I can use that x to plug in for JKM, which I know is 9x minus 5. I can substitute 11.375 for that x. Okay, 9 times 11.375 is 102.375 minus 5. That gives me 97.375. Okay. Okay, so the next question here is to prove that the lines are parallel. Okay, so here I know that R is parallel to S. It's shown by the two red arrows. And I also know that angle 5 is congruent to angle 6. So angle 5 here is congruent to angle 6. Okay. And here, eventually, I want to prove that line L and line M are parallel. Okay, so I'm going to make my proof. I'm going to make my two columns, starting with my statement. Oh, yeah. And then my reason. Always, I'm going to start just with my given. You don't have to. Sometimes the book doesn't because for them it feels more logical, right? They want to bring up that given reason whenever they need it. I just like to do it right to start with. It makes it easier. I know I've covered all my bases. So first, R is parallel to S, and angle 5 is congruent to angle 6. My reason I can say that is that was given. Okay. Then I'm going to state that angle 4 and 5 are supplementary. Angle 4 and angle 5 are supplementary. The reason why I can state this is because these are parallel lines cut by a transversal. That means same side or consecutive interior angles are supplementary. That is the same side or consecutive interior angles theorem. Then what that means is that the measure of angle 4 plus the measure of angle 5 should equal 180. That is the definition of supplementary angles. Definition of sup angles. Okay. Then, since angle 5 and angle 6 are congruent, that means that their measure is congruent. Equals. Okay. That is definition of congruent angles. Def of congruent angles, right? If angles are congruent, their measure should be equal. Okay. Which now, if measure of angle 5 equals measure of angle 6, I'm now going to replace this with angle 6. right? And so I just did the substitution property. Substitution property, okay, which means that angle 4 and angle 6 are supplementary. And I know that because if their measures add up together and equal 180, that makes them supplementary. That's the definition of subangles. And so lastly, that means that angle L, or sorry, line L, is parallel to line M because of the converse of same side interior angles, right? So earlier I used the same side interior angles theorem. If they're parallel on their same side interior or consecutive interior, they're supplementary. Now I'm using the supplementary to prove that they're parallel. So that's the converse of same side or consecutive interior angles here. And I'm done. Okay. If all of these angles were numbered, right, I could even say that, oh, angle 5 and this angle would have been congruent here, right? Because they are alternate interior. And if this and this, that would make this and this congruent because the transitive property, right? And then I can then use the converse of corresponding. But since they only give us this information, then we have to use what we are working with. Okay. So why don't you try CYP3, and then once you're done, come check your answer. Okay, your proof might look something like this, because they were very generic with it. I decided to draw a picture and give something some categories and numbers, right? So I have two lines in my plane, okay? So I named one line P, line line Q, okay? It's cut by a transversal, okay? And then I have a pair of alternate exterior angles that are congruent, and I want to prove that these lines are parallel, okay? This is the converse of the alternate exterior angles. This is just a proof for it, right? So here, I just named some angles with some numbers. Okay, so I started with angle 1 is congruent to angle 3, right? Because the if thing, that's my hypothesis, it's given to me, okay? So angle 1, angle 3 is congruent, it's given to me, right? Then, with this angle, I named it angle 2, okay? And angle 2 and angle 3 are congruent. We know that because they're the vertical angles, and vertical angle congruence theorem tells me that they're congruent. Okay? So if angle 1 is congruent to angle 3 and angle 2 is also congruent to angle 3, I can say that angle 1 and 2 are congruent using the transitive property. Okay? So here, if angle 1 and 2 are congruent, these are corresponding angles. I can then say that the lines here are parallel using the converse of the corresponding angles postulate. The converse of this postulate tells us that if corresponding angles are congruent, those lines are parallel. So there you go. Okay, so last example here, it's to determine whether G is parallel to F. Okay, and what we learned is that parallel lines have the same slope. So we just need to see what the slope is for G and what the slope is for F. Okay, so line G slope. Okay, y2 minus y1, so I'm going to do 4 minus 0 over 0 minus negative 3. 4 minus 0 is 4, 0 minus negative 3 is plus 3, so 4/3. Okay, then my F slope, okay, y2 minus y1, so I'm going to do 4 minus 0 here, and then 6 minus 3. 4 minus 0 is 4, 6 minus 3 is 3, and so here they are parallel, G parallel to F. Why? Because they have the same slope. Okay, and there you go. So why don't you try CYP4 and then come check your answer when you're done. Okay, so here you should have gotten line L is not parallel to line M because the slope for line L is 1/5 and the slope for line M is 1/6. If you got that correct, you can either move on to the construction part, which is kind of bonus, or you can get started with your homework. And then here's your explanation for CYP4 though, if you got it wrong. Okay, so slope for line L, I did 4 minus 3, which is 1. Over 0 minus -5, so that's plus 5, so 0 plus 5 is 5. So that slope for line L is 1/5. Okay. For line M, I did 1 minus -2/3, which is plus, so 1 and 2/3. And then 12 minus 2 is 10. I changed the 1 and 2/3 into an improper fraction, which is 5/3. And what we do when we divide fractions is we keep the first one, so 5/3. We change the second one to its reciprocal, so 10, the reciprocal is 1/10, and division turns into multiplication. Right? Then we multiply straight across. 5 times 1 is 5, 3 times 10 is 30, and 5 over 30 simplifies to 1/6. Because they are not the same, they are not parallel. Okay, so you can get started on homework, or for bonus, you can learn how to construct a parallel line through a point not on the line. Okay? So the first thing you're going to do, okay, is you're going to connect that point to the line you want to be parallel to. Okay, so all I did is I connected it. Okay? Then you're going to open your compass to any width. So again, I'm sorry, my compass is quite weak right now. It's easily moves. Okay, and what you're going to do is you're going to make an arc. Okay? Then, leaving your compass the same, you're going to go to where that point is, and you're going to make that same arc. Okay? Then, you're going to measure how far the arc is from each other using your compass. So here's one intersection, here's the other intersection of the arc. I'm going to move my compass to measure it. Okay. Then, I'm going to go to where it intersected this line, put it here, and then cross it over. Okay. And then, provided that my compass was perfect, I would now have my parallel line. Let me do it again. Okay. And now, I have my parallel line. This is parallel to this. Okay, so let me try it again. Okay. So the first thing you're going to do is that you're going to connect your point to somewhere on the line you want to be parallel to. Then, from where that line that you drew intersects the other line, you're going to make an arc of a certain length. So, again, any length is fine. So here, I'm going to make an arc. Okay. Leaving my compass the same, I'm going to go to the point and make that arc also. Okay. Sorry, it's a little light. Then, you're going to measure how far this arc is from here. And then I'm going to go to here, and then I'm going to make that same. Okay. And where that meets, okay, that's where the new parallel line is going to go through. Okay. And this is now parallel to this. And there you go. That's it. Have a great rest of the day. Bye, guys.